Look, just want to welcome you all again, both to first-time attendees or those that have come back for their second, third, or potentially even fourth TEG risk webinar. Great to have you here. This session, we will be doing a bit of a deeper dive into the often underappreciated reset and restart requirements within modern functional safety systems where it comes to machine safety. KC, who I'll introduce shortly, is going to look into things like manual versus automatic resets, the location of reset push buttons, etc. When does a reset become a safety function, and when might a performance level be required? And he's also going to bring in, I guess, some of the information as it relates to ISO 13849-1 2023. So in terms of that, so we've done a whole bunch of machine safety. It follows through on that, and we'll have more coming in the new year as well. But a little bit about our speaker. So KC is a senior, or Keshawa Senaratne, he is or KC as we know him, as a senior safety engineer within TEG Risk. And for those that haven't had the pleasure of working with him, a highly competent safety engineer with us, has previously held roles with GA Avapac, where he's a lead electrical design engineer, helping them design and build and export globally packaging machinery from around to locations all over the world. So, and he's got very much a full suite of competency or spectrum of competency in that machine safety space. It includes functional safety, hazardous areas, combustible dusts, and is also experienced in aspects as it relates to things like CE marking, so on and so forth. So highly skilled in that space, very much a valued part of the team. And so without further ado, I will hand over to KC, who's going to take us through this. By all means, I encourage people to add their questions either via the chat or the Q&A function, if that's working for you there, and we may address some of those throughout the session as they come up if there's an opportune time, or we'll come to them at the end. So we will sort of certainly allow a few minutes at the end to answer any questions that people may have. And as per previous webinars, for those that have registered, there will be some information coming out with links to the recording and the PowerPoint presentation as well. So you should all have access to that too. And additionally, we will be adding up a web page to our website where we'll be storing all of this historical stuff too. So you'll always be able to go back and get it as a resource in the near future. But without further ado, I will hand over to KC, if you want to take things away for us. Thanks, mate.
Thank you, Hamish. Thanks for that introduction. And it's certainly a privilege to be part of TEG Risk team, supported by an excellent group of safety engineers. And yeah, welcome to everybody who's joined the webinar. I'll share my screen and jump onto the presentation. You guys can see my screen?
We can. Yep.
Okay. Cool. Right. Yeah. Well, Hamish introduced myself, so I'll just go through some of the topics that we're planning to go through during this session. So there's quite a lot of core concepts behind the safety resets, and I've pulled in some of the content from various standards, because when it comes to safety resets, there's a variety of things that sort of come into play. So I could try and sort of build a bit of a broader picture. We'll discuss about the latest 13849-1 on manual resets. I'll have a bit of a comparison between the latest version and the previous predecessor standard around manual resets. And I'll go into some of the important design considerations, things that we sometimes see done well, as well as few things lacking. Some reset implementation topics. These are probably things somewhat debated in the industry. Things like physical and digital resets, manual versus automatic resets, and so forth. And a quick summary of our discussions and open up for Q&A. So, to me, if I were to sort of put safety reset in very simple terms, that it is an acknowledgement that it is safe to start. Safety reset is an acknowledgement that the machinery can be in a safe state to start. And that could be potentially after a safety function has been triggered or after a power restoration. That second point is somewhat missed or very less sort of discussed, that there needs to be an acknowledgement even after power restoration. And the underlying root of the overall concept stems back to restart or prevention of unexpected restart. In terms of unexpected restart, ASNZ 42413 1603, which is the ISO 14118 on prevention of unexpected restarts or unexpected startups, actually. It talks about definitions and key considerations. If I were to sort of highlight this startup unexpected or unintended startups, as per the standard, is startup which, because of its unexpected nature, generates a risk to persons. It can be a start command that can be result in a failure, result of a failure, unintended start command, or even things like external influences such as gravity, load holding, failure of load holding, and so forth. It does not mean a automatic cycling as part of a process function. It's that's intended, that's considered as normal operation. We're purely discussing about restart after a safety function or a hazardous situation or a power restoration. So if we go further into this topic, then the unintended start command or maintain stop command, both of these sort of come into play. It's just not purely on things start moving, things. Prevention of unexpected startups could be looked in these lights, and just bringing some awareness is more to this for consideration. And
probably one thing I'd say is it's quite a technical topic, and Casey and I had a bit of discussion around whether we could actually fit this into one webinar. But there's going to be a balance between those that are technical, that are designing these things, and you might be diving a bit deeper into these standards, and maybe those that are others, perhaps they're in health and safety manager roles. There'll be other bits there where we'll just draw your attention to maybe more systemic, high level things. But yeah, there'll be a lot of references here, and as I said, you'll get a copy of the presentation afterwards where you'll be able to maybe do a deeper dive into some of these clauses later on.
Yeah. Thanks, Hamish. So hence I won't sort of go into all of this. You're able to read through them in the presentation. Start interlock and restart interlock. It's sort of less commonly sort of brought up topics. Are they coming out of the ESPE's standards, electrosensitive protective equipment standards? It's basically talking about machine start and automatic restart. So the controls that needs to be in place to prevent exposure to hazardous situations.
And that earlier comment I made, those IEC references that Casey has given relate to, electrosensitive presence devices. It's getting right down to the weeds, so it's probably a more technical reference there for some of our machine builders and designers and so on and so forth to look into.
Yep. Yeah, and as and into what Hamish said, this is sort of more building up on a bit of a broader picture into what you may need to consider when you're preventing unexpected startups or designing equipment to do that, achieve that. Manual resets coming out of ISO 13849. This is exact clause from the standard. It first talks about re-establishment of safety function by resetting the safety guard that cancels the stop command. That's inferring that reset is intended to cancel the stop command if indicated by the risk assessment, which is also something for you to note and which I will go into a bit more detail later. This cancellation of the stop command shall be confirmed by a manual separate and intended action, which is a manual reset. And I've pulled in some reference from 424/1204, which is the IEC 60204-1 equivalent. Reset shall be possible only by a manual action at that location where the command has been initiated. So this is referring to sort of visibility and line of sight sort of requirements. The reset of the command shall not restart the machinery, but only permit restarting. So in simpler terms, manual reset is a deliberate, separate manual action to confirm that it is safe to cancel the stop command. So it's not a reset. It's not a start. Reset is not a start button. So yeah, things to consider. So going into ISO 13849, the latest standards on manual resets, and I have side by side the latest standard and the older standards highlighted yellow.
Do you mind if I just jump in here, Casey? So maybe for some of our attendees who may not know what ISO 13849-1 is, it's basically a document around the design of safety-related parts of control systems for machinery. And it's the older version that you see there, although actually it might even be older, is actually described as 4024.1503. So 4024, safety of machinery, does include this particular standard of ISO 13849-1, although it's older than what we're seeing here. So these new standards that we're showing you are building on all of that. They're later versions, they're updates at an international level, and probably if people, particularly machine builders or designers, or maybe those that are specifying, if you want to be applying latest available knowledge, you may want to be considering using or referring to some of these latest versions. But if these standards don't look familiar or they look way out of place or out of whack, they are, or certainly variations of this older versions are represented as a part of the 4024 series. Sorry, Casey, where you go.
Thanks. The items highlighted in yellow are the stuff that appears in addition or what's different on the new standard. The items highlighted in green on the other side on your right-hand side is something that is specific around the performance level. So essentially, the new standards adds a bit more depth and a bit more clarity on building up on the previous standard. I'll go into all of these points separately, but just highlighting that some of these additional changes, especially in the top, but discuss a bit more around the what the manual reset means. Down the line, it talks about monitored signal changes. Here it talks a bit more on a manual reset requiring safety function, whereas the previous standard it was just a small sort of more sort of generalized statement there. And also it talks the new standard talks a bit more on additional protective measures other than reset sequencing for protecting against lack of line of sight sort of requirements. Yeah, I'll go into a bit more details down the track. That point Hamish pointed out earlier, the how the ISO 13849-1 comes into the ASNZ 424 framework is that the ASNZ 424-1503 is basically adopted from ISO 13849. However, the current ASNZ 424 is actually referring to a very older standard. In terms of using the latest standards, I would say it from what we can see, it's more of adding more clarification and depth than when you should consider safety function versus when you must versus when a safety function is not required. So these sort of clarifications add a bit more depth. In
They're
terms
going to
of
help. They're going to help our technically minded designers and so on
exactly.
and so forth in terms of less guesswork and more explicit sort of direction. So I definitely, for those, it's reasonably practicable in applying latest available knowledge to be really, really looking at these closely when you're building new machines or carrying out upgrades. Okay.
Yep. I'm sorry, I saw a typo here. It's supposed to be 2006, not 2015. So let's dive into some of these specifics at some time. Some of the design considerations around this, I've just picked some of the common themes here. So this discussion around reset device. Not necessarily on the reset device, but from a design standpoint, it talks about separate, as providing a cancellation to stop command as a separate manual intended action. So a separate reset button is typically used to confirm a safety reset. So you you would generally come across a blue color button, which is typically what we use, and the the requirement for the blue color is basically coming out of 4241204. It talks about these uh, different colors for different purposes and so forth, and that's just to make sure that things are standardized and common throughout the industry. Um, so yeah, a reset is not a start button. It's achieved using a dedicated momentary, usually a normally open push button. Um, must be a physical action by your operator, not an automatic software logic, meaning it's not an automatic reset. The reset function also here talks about only be achieved if all affected safety functions and safety guards are operational, meaning before you're allowed to enable or actuate a reset, um, uh, the uh, the protective measures must be active and um, ready. So, and also uh, the initiation of hazard situation or initiation, a reset shouldn't lead to a hazardous situation by itself. So some of the design consideration to achieve that, I mean, obviously, um, the reset uh, shouldn't shouldn't work. Reset a button should be inhibited if the safety inputs or feedback signals indicate default or open condition. For example, if your guard door is open, your reset button shouldn't work. The reset button only becomes active when all conditions are met, meaning your interlocks are shut, your EDM comes back and say it's okay. One of the best practices would be to use a combined controller logic, say safety OK signal that would enable reset. Some of the pitfalls is that you have multiple different types of whole array of different input devices, light curtains, uh, interlocks, and so forth. But in your program, you might actually miss some or one, some of these different input devices. So a good practice is to combine all of that into a single safety OK signal. And reset re-energizes the safety relay output, but the machine only runs when start is pressed. So this is leading to, a reset is not initiating a hazardous situation by itself. There's discussion around foreseeable misuse and fault detection. So this is actually a additional clarified item on the latest 13949 -1. So it says only be accepted by monitored signal change in order to avoid foreseeable misuse. So it's very sort of prescriptive. Some of the design considerations is basically what it's saying is you're monitoring a state change of your reset. So a rising edge and a falling edge, meaning a button is pressed and released. Something to consider is before you look for the high or rising edge, you should see a low, meaning the reset button has not been pressed, and it's pressed and then released, going back to a low. There's additional things such as timing interlocks you could introduce. So some of these specifics are coming out of um, uh, you know standards like IC 62046, application of protective equipment to detect the presence of persons. So they're somewhat, providing some guidelines as to what this timing interlocks should look like. So between 150 milliseconds to 4 seconds to look for that rising and falling edge. These are things to sort of look for foreseeable misuse, such as somebody holding down the reset button, opening and closing guards, uh, um, or even a fault condition such as reset push button stuck on stuck stuck on position and things like that.
And so in that, there's a lot of very technical under the hood, I guess, design information that machine builders or automation team members may need to be aware of for those that maybe aren't operating in that space. Maybe you're a health and safety manager, or you've got an interest in machine safety, not quite at that level. One of the ways to check that is, like, can the button be held down? Is the reset possible? Like at a simple sort of high level, like, what are our resets like? Can we just tape the button in a down position, and does that work on the system? It's a way, maybe for those that aren't designing, for them to understand, how the resets are configured. So, yeah.
Yeah. One of the ways sometimes I check, the reset is looking for the falling edge, meaning a release function is that you hold the button and see if your reset contact is energized or whether you can start the machine. It needs to be a press and a release. We do come across even safety relays from established manufacturers that aren't capable of detecting a falling edge, which is somewhat surprising, and there are things out there, so things to consider. And adding on to that is also, they're looking for the hold and release is things like, if somebody's leaning against the reset button, it shouldn't, it's not a deliberate action. So these are things to sort of capture that. One of the key things for overall sort of manual reset is the reset location and line of sight. So in order for somebody to acknowledge that the area is clear to now restart the machine, is to be able to see the headset location. We typically find, these reset buttons where you can't really see through the guards to, say, the other side of the machine, or you can basically disappear through the guards and people can wander around. It could be inside perimeter fence guarding, and there could be multiple people now attending inside a hazard zone. And a line of sight is specifically important to make sure that somebody else couldn't close the guard behind you and restart the machine, leading to a very dangerous situation. So this is one of the primary and key sort of requirements, and you'll see that if you cannot achieve a line of sight, then there's various other requirements. So one aspect of that is leading into sequenced resetting. So this is we're talking about multiple resets. One, could be a first reset in a location where you can clearly see the area is clear, and then you come back and reset the master. And there could be timing interlocks based on your risk assessment. If there's a possibility of unexpected startup or a second person being in there while the reset is done from a remote location, then there could be timing interlocks to say um, between the two reset buttons, it needs to be done within a certain time duration, otherwise it'll time out. Or it could be a logic sequence, say guard 1 is okay, guard 2 is okay, the area is clear, acknowledgement, and then the reset button. So if you don't see that order of things happening, then you can't reset. Um, the 13849, also especially the latest standard, elaborates a bit more on using alternative protective measures, such as presence sensing, like light scanners in areas where, although you're walking into the zone through a guard door, interlocked guard door, areas where you don't have line of sight could be protected by a laser scanner. Another common thing is you could use trap keys, even lockouts. So there's things to consider if there's a risk of unexpected startup.
And I think
Um,
this section of slides here, I think, is really useful as well. So while reset design under the hood by our technically minded sort of design engineers, there'll be a whole lot of stuff that can be done for those that aren't. Maybe you're just doing risk assessment, you're inspecting your own plant, having an awareness of these points here, like, can we reset the machine with someone inside the machine? That's something that is, much more systemic and above that sort of design within the software or the wiring, for instance, of the machinery. It's something that, those sort of team members can be contributing to around making sure you've got the right reset functionality and design in your machinery.
Thanks so much. I've pulled in something from IC 62046 that talks about if it's possible for a person to pass through a detection zone of a trip device, could be an interlock, and attain a position that is hidden from a location of the reset control, supplementary protective measures, for example, time-limited additional reset controls inside safeguarded area, presence sensing devices, trap key systems shall be provided. So there are other standards that sort of build on this concept to prevent exposure to unexpected startups. And a final note is here is a chosen method must deliver sufficient risk reduction. So that comment there is laid into the next, which is somewhat sort of misunderstood element of reset design. The latest 13849 really builds on this point where when the reset becomes a safety function. So typically, there's that note down here saying the manual reset functions often is not a separate additional safety function when the safe state is still maintained by a safety function. Example, initiated by a safeguard cover where stepping behind is not possible. So, if you're opening a small interlock guard cover, you can't hide behind it. Your arm or whatever, reaching through that opening would prevent the guard from closing. Your hand or part of your body is in there. So in that instance, the manual reset is manual reset initiating unexpected startup is almost of negligible risk. So because your safety function, the interlock safety function, is what protecting you from unexpected startup. But the point here talks about when the function of a manual reset is required to be a safety function. This is when reset becomes a safety function. Example, prevention of unexpected startup, the required performance level shall be determined. The PL of the manual reset function can be different from the PLR of the associated safety function. So some of these examples of these situations is, as mentioned earlier, full body access through areas where operators can remain hidden from the reset location. Large machinery with obstructed visibility, hazard zones with multiple access points, multiple people can come inside. So in these sort of instances, although your interlock is keeping the access points safe, you could still have people in there, especially when there's multiple operators involved. So the key thing is it really goes back to your risk assessment. Is there a real risk of unexpected startup? And if so, if your reset is what protecting these persons from um, uh, exposure to these hazards, then your reset function needs to be a safety function, meaning it needs to be designed similar to a um, um, interlock. So yeah, I have something from 62046 here. A restart interlock shall be provided except where the risk assessment shows that the possibility of injury will not be reduced by a restart interlock. For example, it is not possible for a person or part of the machine to be in hazard zone without being detected. So yeah, it's just reiterates the same concept. There's additional things on reset becomes a safety function. I found this on a ISO standards associated with presses actually, and it 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 actually prescribed your safety system reset needs to be the same as of safety function of which it is acting. So say if it's an interlock guard that's preventing you access into the press area, then it needs to be the same performance level. I mean, in the same level of safety integrity as your primary safety function.
And I think this probably just highlights or, you know, brings up the point that we've raised in, you know, prior webinars or other sessions we've delivered, where you've got those hierarchy of standards documents, and they're, you know, 13849, which is the same as 4024-1503, which is the design of functional safety circuits. It's a design principles based document. But there may be very, very specific machines, like a press, for instance, you know, things like robots have got very specific requirements. They may actually go in and have very specific requirements in them laid out for you. So it's certainly something to be aware of for those that are doing design, or even those that are perhaps, you know, risk assessing, is compare the machinery that you're looking at with, you know, what's the latest available knowledge and standards in that space. So rather than necessarily having to make lots of determinations around all of those clauses, it may already be spelled out in a specific standard.
Yeah. If I were to just very sort of in simple terms summarize this topic, basically treat reset as part of your risk assessment. Ask if this reset fails, could somebody be injured? If he is, then treat it as a safety function, determine its PLR, performance level required. If no, then treat it as a non-safety function, but ensure the manual reset basics applied. So the things that we've discussed earlier around line of sight and uh, state monitoring and so forth. If the reset requires a performance level, a PLR, then there's a bit more details around, what you can sort of consider and what a single channel push button would achieve. But yeah, I won't go into this. We could probably do a whole webinar on this. So yeah.
And just a note there, we've had a question from Alton regarding auto resets and nuisance triggers. We have got some slides coming up on auto resets, so hopefully that will answer your question. If it doesn't, we can come back to it, Alton, but it's also a reminder to everybody else out there that if you do have questions, please chuck them in the chat or the Q&A so that we can address everybody's needs. Thank you. Way to go, Casey. Sorry.
So some implementation topics. So this is the discussion around auto resets here. So there's definitely was this conversation around physical versus digital resets. There's definitely preference for physical resets, meaning physical push button. A digital a reset would be a button on HMI screen, for example. By having a physical reset push button, say, it's a dedicated device or component, dedicated purely for the reset function. It's not sort of hidden away in a HMI somewhere, or it's not a start button. The same button shouldn't be used for reset and restart. By having a physical button, it's more of a deliberate action. It's more robust, so and less prone for accidental activation because of various basic, fundamental design principles. Edge detection versus this is a electrical edge detection, rising edge, falling edge for a button press and release versus a logic bit inside the software. So it's a bit more sort of robust. By having a safety push button, you can locate it in a place where you have direct line of sight to the hazard zone, whereas you might find it difficult in a HMI. Less prone to glitches. HMIs can can freeze, comms can drop out. Things like that can potentially generate unsafe reset behavior. Push buttons are simpler to validate, and so forth. So I'll just
Probably just back on that previous slide, just very, very quickly. So digital resets on your HMI are possible. There are trade-offs. They just need some serious consideration. And if you've got a machine that has additional risks around unexpected startup, where you actually need to achieve, for instance, performance level C or higher, you won't be able to do that with a digital reset because complex electronics or complex components are very limited in what they can achieve from a performance level perspective. So physical preferred, digital possible, just trade-offs and considerations required to see if it's actually possible.
Yeah, and adding on to that, there's sometimes the benefits of HMIs where you could prompt the operators to go through a certain checklist. All of these things. Guards are closed, no personnel inside, and so forth until the reset is enabled. So there are definitely benefits of having a digital reset, but it could be a fault clearing / checklist on HMI alongside a reset push button. That might be a better way to achieve that. Automatic presets. Yeah, the automatic resets of a safety function is appropriate in situations where continuous detection of an individual prevents the hazardous situation. So um, it leads back to the risk assessment. If the risk assessment confirms that it does not increase hazardous exposure, then it is possible, and especially using things like presence sensor device initiation (PSDIs). I have some uh, example here, but you will see there's some issues with this. So this guy is operating through a automatic reset. I think he is using a foot switch as well. But the issues you might be pointing already that that everything is wide open. You know, although he's putting his hand through here, he can also put his hand outside of this um, detection or the light curtain or under the light curtain. So this is a possibly a option where you might be able to use automatic a reset type of setup where it's the hazard zone is fully enclosed, um, and the you cannot physically get in there, and you cannot be behind the protective devices. Um, for it to operate. The other things to consider is, you're reaching in, reach in, reach through, reach over, reach under distance, okay, including the resolution of your protective device. Say you cannot put your hands through the light beams, um, and also things like the stopping times. So if you push your hand through, can the moving parts stop quick enough for it to not cause any injury? So there's quite a few things to consider there. I think we're right on time there, Hamish. So some of the key takeaways. If I were to summarize, reset is not a start button. A reset is what enables for you to start the machine. Manual reset is essentially a default option versus digital and automatic resets. Physical resets are preferred. Reset must be conditional on safety status. So your protective devices must confirm that it's safe to reset and then restart. Visibility of the hazard location is key. So if there's a risk of unexpected startup, and if your reset is the one thing that's stopping that, then the reset button needs to be a safety function based on the risk assessment. And some of the common pitfalls are the use of same button for start and reset. Often HMI fault clear is used as a reset input. Automatic reset after power restoration. That's potentially a big sort of risk item. Very rarely discussed. Reset within reach of the hazard zone, so without visibility. So say light curtain or safety guard, you can go inside, but you can reach over the guard or through the guard and reset the button while being in the hazard zone. People do that to try and bypass the safety to try and work in the machine while it's moving and stuff like that. Unmonitored reset inputs. So no rising edge, falling edge monitoring that can potentially lead to misuse or faults. So I think that's pretty much
Yeah.
it. These are some of the references I've used, and there's a lot more to research than that. Yeah, and yeah.
Okay, couple of questions. Thanks, KC. Yogesh, I think we've got a question here. Just interpreting that, would a SCADA reset be considered part of a physical or digital button? I'm assuming you mean SCADA on an actual screen, if that's what you mean, Yogesh. So did you want to touch on that, KC?
Yeah, if it's a if going by a SCADA reset and being a digital, I would say, and yeah, it's coming back to that physical versus digital. I would I would I would prefer to use a physical button, but say if you have a multiple, large factory and you have multiple resets, you got sequence resets in place, your local specific acknowledgements needs to be more of higher safety integrity than your final safety reset, because your localized resets are what confirming that the area is safe to start. So I think it's somewhat subjective, but in essence, I feel like it's more of a digital reset as opposed to a physical reset. So if it's possible, I would prioritize on providing a physical reset button.
Okay,
Yeah.
thanks. KC, let us know, Yogesh, if that didn't answer your question. Alton, you had a question around on a laser scanner setup. If the zone interruption is less than a certain time, would auto reset be acceptable? Sounds like there's a few things going on in a question like that. This would reduce nuisance triggers. I think KC touched on the fact that auto resets, there's pretty high barrier of things that you have to satisfy before they sort of become viable, I guess, design features, in terms of, being absolutely certain that, no one's in a hazardous zone, plus a few other bits and pieces that were mentioned. So probably need to get a little bit more detail on that and can do that afterwards, Alton, if need be. I've got a question from Andre. I'm definitely going to hand this over to our electrical engineer here, Casey. If manual resets are not required to be part of a safety function as per a risk assessment, what are the benefits of terminating the reset into a safety rated IO, i.e. help prevent remote reset?
Good question. I would say the the overall safety, the level of safety integrity is much higher, and your overall safety logic is contained within that one controller. Less prone to errors, a better response time. You can use the pre-validated function blocks to run your safety function. Those would be the benefits, as well as the pre-validated function blocks would have your edge monitoring and stuff like that. Whereas if it's going through a PLC, then you'll have to do that separately. So those are the benefits. If the safety reset doesn't need to meet a certain performance level, yeah.
Okay, let us know if that didn't answer that question there for you, Andre. We've got another one here. What kind of documentation or evidence do auditors typically look for to justify the reset method chosen, or is it simply a matter of just pointing back to standards? Probably that's my experience is, I guess, over time and experience, you're always going back and looking at those standards. I think the power of a presentation like this, combined with the standards and AI, is that it's probably relatively easy to maybe pull together a checklist on that front. Might be worth having a crack at. But Casey, have you got any sort of comments
Yeah,
or clarification points on that?
yeah. I mean, fundamentally, it's your risk assessment, right? If it's a very straightforward, you know, a protective measure such as, interlock cover, you might not even think about resets. But if it's a full body access, then you'll have to think about a really unexpected startup, and also having more than one person being in the zone at one time. Then all of those reset um, locations and so forth come into play. So that would be your fundamental requirements. You'll capture that at the risk assessment level. So risk assessment records would be your evidence. And in those risk assessments, you could pull in things like references from standards, say type C standards, such as very prescriptive about your reset requirements. The other thing is, if your reset needs a safety function, then you need a safety requirements specification to provide more design specifications on what your reset needs to be. Then validation, as-built validations, so records of as-built validations, as opposed to sort of complete the loop.
So yeah, type C standards may have that information for you. There's going to be built within the different standards like 13849 or potentially the ESP ones that you can extract out as well and make use of. And certainly, validations or SRSs should be within the design documentation, should be taking into account that and specifying those. And that should flow into validation plans for those that are doing that work on designs. Effectively, the checklist coming out of that validation plan. Any other questions? Just making sure I've got everything. I heard a ding, I thought, maybe. We've got a new question that's come in from Yogesh. We've got, what would the main difference in the higher performance level required reset and the lower performance level required reset? Is there a reference of standard to say how it should be wired and function? Do you want to comment on that, Casey?
Yeah, there could be two folds to that question. So the safety function and the reset performance level doesn't necessarily need to be the same. The reset could be slightly lower, typically because a frequency of unexpected startups from happening because you have a primary safety function could be a bit less. And yeah, so if you follow the performance level a tree, you'd be able to get there. The second element to that is in terms of your safety related control system architecture and design, you would go to ISO 13849-1, and it talks about if you need to meet only performance level C, then you could do it with a category 1 system, even a standard push button with single channel logic controller and output. So that's very easy to achieve. But if you need a performance level D, for example, then you could be looking at a category 2, easier to do it, a category 3. Then you'll have to design as a almost a
more IO,
OIO,
more safety parts, etc. So yeah, just extra there. I'm conscious, sorry to cut you off there, Casey. Conscious of the fact that it's now 1:01. We thank everyone for taking their time and their lunch breaks to come on board. Thank you, Casey, for presenting. hopefully we've got the questions there addressed and answered. As I said, anyone who's registered for this, even if they didn't attend, you will get some comms come out where you'll get the presentation and access to the video. So you'll be able to go back and revisit it if you need to, or possibly share amongst others within your team. But a big thank you to everyone in KC. Thanks very much. Any final things from you, KC, before we sort of close this out?
No, I think we've covered everything, and yeah, thank you everybody attending the webinar, and hopefully